Okay, we're looking at lesson 6, and I want to start this off by apologizing to my good friend Adam Johnson, who took time out of his morning to film this entire thing. And then because the camera is a little bit older, it ended up rewinding at some point and ended up going over almost everything that he filmed. So what he did earlier is I had him start out with this. Now what we have is a unit circle with a radius of 5, or just a circle with radius of 5. And we have a point on the circle at 4, 3, and I asked him to label it. And so, of course, what he did was, remembering some of his math from high school, he went ahead and labeled the sides of that triangle, 4 and 3, 4, of course, being the x portion, or the unit on the x-axis, 3 being the height on the y-axis, and then because we have a radius of 5, that it also is the hypotenuse of our triangle. Okay, then the next thing he did is went down and it said place the labels sine and cosine theta on the appropriate sides of the right triangle in the following diagram. Okay, well, if we want to do that, then we could do this. Now, here's the thing. What we're trying to get at was the relationship between the x value on a unit circle and cosine theta and the y value and sine theta. So normally when we see points on the unit circle, or always I should say, what we're looking at is for our x and y is the cosine and sine theta. What we're going to do is, instead of trying to take one of the dry erase compasses and draw a circle and have somebody mark out all of these, we're going to use a unit circle board that's already been created. Now we're not using actual measurements. As you notice, we're not going to actually measure, is it a foot, anything like that. What we're going to do is we're just going to show that on this circle, and the one that I chose is the one that I highlighted here in green, that we're going to use spaghetti to mark our units. Okay, so the first thing I want to do, because the circle is a little bit less than the length of the spaghetti, is set it up there, find that point, and break it off. So this piece of spaghetti is going to be our min and max. So on my x-axis I can take this and I can set up my 1 and my -1 on the y-axis, I should say. And we're going to take pieces of spaghetti and we're going to make them the same length as the vertical lines that we draw from the 15 degrees, from 30 degrees, from 45 degrees, etc. Okay? But before we do that, what we're going to do is we're going to take a piece of string and go around the unit circle that we have, and on that piece of string, starting from the end of it, I'm going to go ahead and mark off every 15 degrees. So we're going to work the rope around and show you how to do that. Then taking that piece of string or rope, okay, we're going to lay that flat, so we're basically going to take a circumference and change it into a linear dimension. And on the whiteboard, we're going to go ahead and mark every 15 degrees on the whiteboard, and that's going to be the increments on our x-axis. Use some gray 550 cord, because if I mark on it with this, it's going to show up a lot better. So you just start just by taking the end of it, placing it here at 0, and starting to work your way counterclockwise, going around and making marks every 15 degrees until you get back around to 360 or 0. Okay, what I did is I took my piece of spaghetti that I have for the radius of the circle, and I went ahead and created marks at 1 and at -1 with that piece of spaghetti, so we know what our limits are. So the next step is to take the string that I made all of my marks on, and I'm going to set the end of it right at the origin. And then everywhere I have a black mark for 15 degrees, I'm going to take a dry erase marker and mark those increments. And we're going to continue this on until we get to 360 degrees. I have is tick marks that go along a line, and what I did is I used a little bit of art tape to put on my board, and it will go every 15 degrees to 360. And of course we also have our range, our 1 and our -1 marked. So now what we're going to do is we're going to go ahead and snap spaghetti, that is the height of our Y value, on the unit circle, and then start transferring those onto the board. Okay, so as you can see, all I did is draw some vertical lines going from every point on the unit circle in the 15-degree increments. And all we're going to do is just take a piece of spaghetti, put it on that line, measure it, and then snap it off. So this little piece represents the height, or the Y value, at 15 degrees. Okay, so what I'm going to do is continue that with all of these, going all the way around the unit circle, and then take these and transfer them. So on my number line at 15 degrees, I will have a height of this above the x-axis. So I have my piece of spaghetti for 15 degrees, so all I'm going to do is just place it on the axis and make a mark. And then I have my piece for 30 degrees, so the same thing. At 30 degrees, set my Y height, and then for 45, set that for 45, and do that. And this is going to continue all the way on to 360, so for the sake of time I'm going to stop the video and go ahead and make these marks. Pieces of spaghetti, and lining them up on the x-axis is going to be all of these dots that look like this. Alright, so if we connect the dots, we're going to notice that we get a sine curve. Okay, so I went ahead and connected all of the dots, and we get what relatively is a sine curve, okay, based on the precision that we're using with pieces of broken spaghetti. Okay, so now what we're going to do is something very similar, but we're going to do it with the x values. So over here on our unit circle, we're going to measure the x values to each one of those degrees, and we're going to go ahead and plot that out on our axis over on the right hand side here. Okay, before we go on, we're going to discuss a couple things that my friend Adam covered earlier before his entire presentation was deleted. Okay, the reason that we measured the Y values is, like we showed at the beginning of the video, that this is going to represent our sine. So that's why the lengths that we got off the Y values from the unit circle drop down perpendicular to the x-axis end up making a sine curve. So next, of course, what we're going to be doing is measuring the x values from the origin, or from the center of our unit circle. And when we put that on there, also vertical, this is something that the kids might get confused on, we also want to stand those vertical on our axis and everything to make the cosine. That's going to make our cosine curve. Now, a couple questions that he had answered is, what is the period of the sine curve, or the wavelength? Okay, well, it's 2 pi. As you go down the line, when you hit 360 degrees, that's going to be the same as 2 pi, okay, which is also shown on our unit circle here. Okay, after 2 pi radians, it's going to repeat, or after 360 degrees, it's going to repeat. Okay, our zeros on the sine curve were at 0, 180, and 360, okay, which we'll show in a second. And of course, that's just wherever it crosses the x-axis. All right. So what we did is we started out here, and so it touches the x-axis here at 0, goes up to 90, comes down, crosses and goes to the underside of the x-axis at 180, comes back up after the minimum at 270, and touches the x-axis again at 360. Okay, the max and min are going to be over here at 90, and then over at 270 is where the max and min of our function are. And of course our y values are going to be -1 and 1 for the minimum and for the maximum. Now that's just one unit. In this case, it's one spaghetti unit. It is nothing particular, one unit that we based off of this right here. Okay? It says imagine this function as it continues in both directions and explain how you can predict the value of 390. Well, what he had said was that if you just take 390 minus 360, you end up with 30 degrees. Because it repeats after 2 pi radians or 360 degrees, the value of 390 is going to be the same as 30 or pi over 6. Okay? And it says explain why sine of 30 is equal to sine of 150. Well, the explanation that he had given is that it's because it's symmetric across this y-axis. If you look over here, 30 and 150 are at the same points, and you can verify that by the length of spaghetti that we broke off and everything. Okay, so because they're both above the x-axis and they're symmetric across the y-axis, okay, the sine or the height is going to be the exact same for each one of them. All right, so now we're going to go ahead and measure from the center of our unit circle over to our x values, and I'm going to go ahead and plot those on there. And then we're going to cut to part of what Adam actually did and show you how he did it. And he's going to take the spaghetti and go ahead and do the same thing we did with the y values and measure from the origin to each one of those x values, and then transfer that over to our board over here on the side. Okay, so Adam has gone ahead and taken all of the x lengths from the spaghetti from the unit circle and transferred it onto our graph along with the sine x graph. And by connecting all the dots and creating a curve, he's created y equals cosine x. So now that you can see these two together, in what ways do the sine and cosine graphs look similar?
They both have a wavelength of 2 pi. They have a minimum and maximum of 1 and negative 1, and intercept at 180 degrees apart.
Okay, and so how do they look different though?
The y equal cosine x horizontal has a shift left of 90 degrees, and it intercepts at the 90 and the 270 degrees, and maximum at the 0 and the 360s.
Okay.
And 180.
All right. And so, will these sine graphs continue infinitely in either direction?
Yes, we can go clockwise on the unit circle and the graph, and basically it'll go from 0 to negative 15, negative 30.
Okay. And what would you say the domain and range of y equals sine x is?
Negative infinity to infinity.
Okay. And what about the range?
The range is negative 1 to 1.
Okay. And what about the cosine graph? Is that going to go infinitely in either direction as well?
Yes.
Okay. Same reason?
Yes.
All right. Okay. And the domain and range of y equals cosine x?
It would be negative infinity to infinity.
Okay. And the range?
The range would be negative 1 to 1.
Okay, this is part 2 of Project 6. We're looking at trig. As Adam demonstrated, we could use just any measurement for the circle, for the unit circle, and just show the relationship between the x and y values and how we can create the sine curve and the cosine curve. And so what we're going to do is look at GeoGebra real quick and explain how the unit circle is the source for the generation of the trig functions. And we're going to look at sine and cosine first. So what I did is I created just a unit circle with a radius 1, as you can see on the y-axis there, and a point B on the circle that moves around, and it maintains a right triangle with the x-axis. Okay, a right angle. So we have this point C that slides up and down, and you can see that my angle is changing. Okay, so what I did is I created the x-axis in terms of pi and 2 pi, etc., to show those intervals. So what I'm going to do is I'm going to start out over here towards 0, and I'm going to turn on this point N that I created. And what point N is the angle between 0 and the point that I'm moving around. That point B and that's going to be my x value, and the y value is going to be whatever the y value of b is. All right, so as we move b, you're going to see that point n moves. Now, to get an idea of how it moves and what it creates, I'm going to go ahead and turn the trace on. Okay, so let me zoom out a little bit so that you can see the entire period to 2 pi. And if we turn the trace on for n and we begin to move this around, you can start to see, if I can get it to fill in some of those gaps, that it's creating the first part of a curve starting at the origin. And as b moves around to 180 degrees or pi, that n is intersecting pi. Now if we continue going around the unit circle, you're going to see at, let's try and get it down there, that at about 270 degrees or 3 pi over 2, that we're reaching a minimum. And that if my angle continues to go around to 360, then we come back over to 2 pi. Okay, so we'll try and fill in some of those gaps on there. Alright, so you can see the relation there just by taking the angle as our x value, which is what we have here. It displays it in radians here, but it's showing it as degrees on here. And our y value being the distance from the x-axis to the point B on the unit circle, we just created a sine curve. Okay, so the unit circle was just used to create a sine curve in that fashion. Now let's undo that, and we'll turn off point N, and what I have is another point Q. And this point Q is very similar, except that it's not working off of the y value of b. What it's working off of is this distance here, which is the x value of b, or in my case it's the length of segment h. And so if we start from 0 up here, we notice that as we move around, that we get, as we come over to 360, we get the cosine curve. And we'll go ahead and we'll try and clean up some of the blank spots that left on that. Okay. But you can see the point Q move around, and so that's going to give us our cosine curve. So if we turn both of these on, both N and Q, we will actually get the cosine and the sine curve exact, or very, very, very close to the drawing that Adam did on the board earlier.